Welcome, curious minds and sleepy thinkers. You've found a soft place to land where the questions are big and the pace is slow enough not to jolt you out of your pillow cocoon. Tonight, we're going to gently tiptoe into one of the most mysterious questions ever asked. How far can we truly go? From the first steps on the moon to robotic landings on Mars, humanity has begun to stretch its fingers into the vast cosmic ocean. But in the grand scale of the universe, we've barely dipped a toe in the water. Could we one day journey beyond our solar system, reach another star, or even another galaxy? But don't worry, we'll take it slow. This isn't a race through equations. It's more like floating through a galaxy of ideas with a cup of chamomile tea, letting the vastness of space wash over us in a peaceful, thoughtful way. The human spirit is a restless thing. For as long as we have been able to look up to see the vast velvet blackness, punctuated by a million distant diamonds, we have asked a singular question. What is out there? This simple query, a whisper carried on the night wind, has driven us for centuries. It began with quiet observation, with ancient people finding patterns in the celestial dance, using the moon and stars to tell time and to navigate. Later, it bloomed into a scientific pursuit, with telescopes extending our sight far beyond what our eyes could perceive. And now, in this modern age, it has become a physical journey. We have begun to stretch our fingers into that cosmic ocean, taking our first timid steps away from our home world. These first steps have been both monumental and humbling. The footprints left on the lunar surface, a stark contrast to the perfect dusty ground, were a testament to our ingenuity and courage. It was the first time we dared to leave the cradle of Earth. But even as we celebrated that victory, we understood its scale. The moon, our closest neighbor and constant companion, is just a few 100,000 kilometers away. In the immense emptiness of space, this is less than a breath. From there, we have sent our robotic messengers. These patient, unblinking explorers have landed on Mars, a planet that feels both familiar and alien, a rusty red desert with ancient riverbeds. They have flown past distant worlds like Jupiter and Saturn, their majestic rings and swirling storms captured for us to marvel at from afar. But in the grand, breathtaking tapestry of the universe, all of this is barely a toe dipped in the water. We are still firmly planted in our own small local cosmic neighborhood, our solar system. The questions still linger, and they now feel even more urgent. Could we one day journey beyond this familiar place? Could we reach another star or even another galaxy? And what in this immense silent darkness stands in our way? Is it a matter of technology, of time, of the very limits of our biology? Or is it something else entirely? To even begin to grasp these questions, we must first learn a new language, one that can describe distances so vast they defy our imagination. Let us think for a moment about the words we use to measure our own world. We talk in meters, in kilometers, in miles. These are units we can feel and touch. The distance of a walk, the length of a road trip. A kilometer is a nice tidy number. We can picture it in our minds. But if we tried to describe the distance to the nearest star in kilometers, the number would become a meaningless jumble of digits. It would be a number so long and unwieldy that its immensity would be lost. We need a new way to measure one that is built for the emptiness between worlds. And so we must drift into the beautiful poetic idea of the light year. A light year is a lovely paradox. It contains the word year, which makes us think of the slow, rhythmic passage of time, of seasons, changing of birthdays and anniversaries. But it is not a measure of time at all. It is a measure of an unfathomable distance. A light year tells us how far light, the fastest thing in the universe, can travel in one Earth year. To understand its scale, we must first appreciate the speed of light. Light moves at a blistering pace, about 300,000 kilometers per second. It is the cosmic courier, a messenger that carries information across the universe in the most efficient way possible. If you were to point a flashlight at the moon, the light would reach it in just over a second. That's how fast it is. A light minute is the distance light travels in 60 seconds, enough to get from the Earth to the Sun. A light hour is 60 times that. A light day 24 times more still. And a light year, our ultimate unit, is the distance this tireless messenger can travel in 365.25 days. The number itself is staggering. In kilometers, 1 light year is exactly 9,460, 730, 472, 580.8. It's about 5.88 trillion miles. It's a number so vast that it ceases to be a number in our minds and becomes a feeling of immensity, of separation, of deep cosmic loneliness. It's a number that makes us understand why we are so isolated in this vastness. Our nearest star, Proxima Centauri, is about 4.24 light years away. Even traveling at the speed of light, it would take more than 4 years to get there. And no one can travel at the speed of light. This beautiful yet humbling unit became popular after the work of Friedrich Bessel, a German astronomer, in 1838. Bessel was the first person to successfully measure the distance to a star other than our Sun. He studied a star called 61 Cygni, and using a clever instrument and a method of measurement that we will explore in a moment, he calculated that the light from that star took about 10.3 years to reach Earth. While he didn't call this a light year hineger, his work planted the seed of the idea. It showed us for the first time that the stars weren't just pinpricks of light in a dome, but were incredibly, impossibly far away. For astronomers, however, there is another unit, one that is perhaps less poetic, but more mathematically elegant, the parsec. The word itself is a quiet blend of two ideas, parallax and arcsecond. A parsec is about 3.26 light years, or 265 times the distance from the Earth to the Sun. It's a number that astronomers use because it's a natural fit for their measurements, a unit born directly from their tools and techniques. The idea of a parsec comes from something called parallax. Parallax is a simple concept, one you can demonstrate for yourself. Hold your finger up in front of your face and close one eye. Notice its position relative to the background. Now switch which eye is closed. Your finger seems to jump to a new position. The closer your finger is to your face, the bigger that jump. This is parallax, the apparent shift in position of a nearby object when viewed from two different locations. Now let's take that simple idea and move it into the cosmos. Our two viewpoints are not our eyes, but the Earth at two different points in its orbit around the Sun. Astronomers take one measurement of a distant star when the Earth is on one side of the Sun, and then they wait 6 months for the Earth to move to the other side of its orbit, a distance of about 300 million kilometers. They then take another measurement. The star, if it's close enough, will appear to have shifted its position ever so slightly against the backdrop of more distant unmoving stars. This tiny shift is called the parallax angle, and it is measured in arcseconds. An arcsecond is a mind-bogglingly small angle. It's 1/3600th of a single degree. Imagine dividing a full circle into 360 degrees and then dividing each of those degrees into 3,600 more pieces. That is an arcsecond. And here is the elegant part of the parsec. 1 parsec is defined as the distance at which the Earth-Sun distance would appear to cover an angle of exactly 1 arcsecond. It's a perfect, neat little trick of geometry. If a star's parallax angle is 1 arcsecond, it is 1 parsec away. If the parallax angle is half an arcsecond, the star is 2 parsecs away. The math becomes a simple reciprocal, a quick and easy calculation that makes the work of astronomers much smoother. While scientists may prefer this technical term, the light year still holds a special place in our hearts. It feels more intuitive, more poetic. It connects distance to the very idea of light and time, two of the most fundamental forces in the universe. As we move through our cosmic neighborhood, we must use both of these terms, these different lenses, to make sense of the scale. Our local distances are measured in a multitude of ways. The distance from the Earth to the Sun is called an astronomical unit, a much smaller yardstick for a much cozier space. It's about 150 million kilometers, a comfortable, comprehensible number. Within our solar system, we can talk in light minutes or light hours. Light takes about 8 minutes to reach us from the Sun, so we see our star as it was 8 minutes ago. If it were to suddenly wink out of existence, we wouldn't know for a full 8 minutes. This simple fact reminds us that even within our own backyard, we are always looking into the past. But once we step beyond the edge of our solar system, beyond the Oort cloud, that distant icy shell of comets, our small units become useless. This is where the light year and the parsec truly shine. They give us a sense of the vast, almost unimaginable gulfs that separate the stars. Proxima Centauri, our nearest stellar neighbor, is 4.24 light-years away. To get a sense of this, imagine all the stars in our galaxy as tiny grains of sand scattered across a vast desert. Our Sun would be one grain, and Proxima Centauri would be another a few feet away. But to travel that distance would take a human lifetime, and then some. The Pleiades, a beautiful cluster of stars often called the Seven Sisters, are about 130 parsecs from Earth. That's roughly 420 light-years. The center of our own galaxy, the Milky Way, is more than 8,000 parsecs away, a journey of 26,000 light-years. The Milky Way itself spans about 34,000 parsecs, or 110,000 light-years across. It is a vast, swirling city of stars, a cosmic metropolis so large that light takes over 100,000 years to cross from one end to the other. And this is just our home. When we look even farther, the numbers become even more staggering. We are no longer talking about light years, but about megaparsecs. 1 megaparsec is a million parsecs, or about 3.226 million light years. This is the unit we use to describe the distances between galaxies. The Andromeda Galaxy, our nearest large galactic neighbor, is roughly 780 kiloparsecs away. That's 2.5 million light-years. A cosmic suburb, yet an immense distance. The Virgo cluster, a collection of galaxies, is about 16.5 megaparsecs away. And the most distant objects we can see, like quasars and the Sloan Great Wall, a huge cosmic structure, are billions of light-years away. We see them not as they are now, but as they were billions of years ago when the universe was young. We are looking into the deepest past, a window into the universe's history. This beautiful, terrible, humbling scale is the true challenge of our species. We are small, fragile creatures bound to a single planet by a force of gravity. We are made of stardust, yes, but we are also made of water and air, of things that can't survive in the cold vacuum of space. The vast distances between us and everything else are not just numbers. They are a physical and psychological barrier. They are the great silence that fills the space between our world and the next. And so we must ask ourselves once more in the quiet of our minds, as we lie here looking up at the ceiling, what is out there and how far can we truly go? Perhaps the answer is not a single point in the future, but a continuous journey, a slow, patient unfolding of our own potential. Perhaps the real destination is not a distant star, but a deeper understanding of our place in this grand, mysterious cosmic dance. For now, let us rest in the knowledge that we have begun the journey and that the stars, no matter how distant, are always there, waiting for us to wonder. The first step in this journey of understanding is simply to let go of our earthly scale, to allow our minds to be stretched and expanded by the numbers, to accept that we are living on a tiny blue-green marble in an ocean of unimaginable size, and to feel not fear, but a quiet awe at the thought. The universe is not a small, tidy place that we can fit inside our heads. It is a wild, untamable thing, and our smallness in the face of it is the very source of its beauty. We have a long way to go, but we have already come so far, and that in itself is a truly amazing thought. Let's imagine for a moment the kind of life we might be living were we to ever make this journey. The ships would not be like the sleek silver rockets of our imagination. They would be more like houses, self-contained worlds designed to sustain life for generations. They would be slow, impossibly so, and the people on board would not be explorers in the traditional sense, but pioneers seeding the cosmos with new human stories. They would be born on the ship, live their lives, and pass on the torch to their children, who would continue the voyage. The destination would be a myth, a distant promise, a star that their ancestors had only seen in pictures. The journey itself would be their entire world, their culture, their religion. This is the true scale of the light year. It is not just a number on a page, but a profound redefinition of time and purpose. It takes a certain kind of courage to embark on such a journey, not the courage of a hero in a battle, but the quiet, enduring courage of a gardener planting a tree that they know they will never see fully grown. It is the courage to believe in a future that is not our own, to lay the groundwork for something so much bigger than ourselves. And in that sense, we have all already taken the first step. Every time we look up at the night sky, every time we feel a quiet sense of wonder, we are sending a part of ourselves out into that cosmic ocean. We are acknowledging the vastness, and in doing so, we are making a connection, a small intangible bridge between our tiny world and the infinite universe. It is a bridge built not of steel and fire, but of curiosity and awe, and it is the most powerful bridge of all. If the vastness of space is an ocean we have barely touched, then our moon is the small familiar island just off our coast. It is our constant companion, a silent traveler that has orbited our planet for billions of years, witnessing all of Earth's history from its own quiet, dusty perch. While the distant stars call to our ambition and our wonder, the moon holds a special place in our hearts. It is a part of our folklore, our myths, our poetry, and our science. It has guided sailors and inspired lovers, and it has been the first world beyond our own that we dared to touch. It is the beginning of every journey outward, a stepping stone and a guide. Let's turn our attention now to this gentle neighbor, this nightlight in the sky. It moves around the Earth at an average distance of about 384,000 kilometers. To put that in a perspective, we can feel it is roughly 30 times the width of the Earth itself. It's a distance that a fast jet could cover in about half a day, yet it feels to us like an eternal, unbridgeable gulf. The moon is not merely a distant light. It is a massive, tangible world made of rock with its own mountains and plains, its own dramatic history etched into its face. One of the most fascinating things about the moon is the elegant ballet it performs with our planet. For billions of years, it has been locked in a gravitational embrace with Earth, a perfect synchronized dance. The moon's journey around the Earth takes almost the exact same amount of time as it takes to spin once on its own axis. This is why we only ever see one side of the moon. This phenomenon is called tidal locking. It's as if a great invisible hand has taken hold of the moon and slowed its spin until it matched its orbit, so that it forever shows us the same unblinking face. This isn't a magical coincidence, but a result of a powerful gravitational tug-of-war. The Earth's gravity is far stronger than the moon's, and in the distant past, our planet's pull stretched and squeezed the young moon, which was still hot and pliable. This constant stretching created friction, and that friction acted like a brake, slowing the moon's spin until it settled into this perfect, harmonious rhythm. It's a quiet testament to the enduring power of gravity, a force that can shape not just the orbits of worlds, but the very way they spin. We call the side of the moon we can't see the dark side. But this is a lovely misnomer. The moon doesn't have a permanently dark side. Just like Earth, it is constantly bathed in sunlight as it orbits our sun. During the new moon phase, when we see a black disk in our night sky, that is the side of the moon facing us, but it is actually the far side that is fully illuminated by the sun. The so-called dark side is simply the far side, and it receives just as much light as our near side. It's a reminder that our perspective is just one piece of a much larger cosmic story. But even with this constant phase, we do get to see a little bit more than we think. The moon's orbit isn't a perfect circle. It's a slightly stretched oval, and it has small gentle wobbles. Because of these tiny shifts in its motion called libration, we can actually catch glimpses of about 59% of its surface over time peeking around the edges, like a curious friend trying to get a better look. Now let us think about the moon's physical presence. Compared to our Earth, it is a much smaller world. Its diameter is about 3,474 kilometers, which is a little more than 1/4 the size of Earth. To put that into perspective, the moon is about as wide as the continental United States. Its total surface area is about 38 million square kilometers, roughly the size of both North and South America combined. So, while it may seem tiny and distant, it is a significant world in its own right. Yet its mass is much, much less. The moon is only about 1.2% the mass of Earth. This means its gravitational pull is far weaker. If you were to stand on the lunar surface, you would feel much lighter. The moon's gravity is only about 1/6 of what we feel on Earth. So if you weigh 60 kilograms here, you would weigh only 10 kilograms on the moon. This is why we see astronauts bounding across the surface in those old films. They are not jumping. They are simply walking in a world with a much gentler pull. This difference in gravity is a profound characteristic of the moon. It's what allows us to dream of giant leaps and soaring jumps of a world where our bodies are no longer so tethered. It's a feeling that we can only experience in our dreams or in the stories of those who have been there. It is a world where weight is a memory and movement is a kind of slow, elegant flight. But the moon in its turn exerts a powerful influence on our home. The most obvious and constant effect of its presence is the ocean tides. Twice a day, the seas of our world rise and fall in a rhythmic pulse. This happens because the moon's gravity pulls on Earth's water, creating bulges on both the side facing the moon and the opposite side. It's not a simple pull, but a complex dance of forces that affects every shore, every beach, every living thing in the ocean. The sun also plays a part, of course, adding its own gravitational pull to the equation. And when the sun and moon are aligned, their combined forces create the powerful spring tides that can reshape our coastlines. The moon's pull doesn't just affect the water. It also tugs at the solid ground beneath our feet. The Earth's crust rises and falls by about 10 centimeters with each lunar cycle, a gentle, imperceptible breath that the planet takes every day. This constant tugging, this rhythmic pull, has a much deeper effect. Over eons, the moon's gravity has helped to stabilize our planet. It keeps Earth's tilt, the angle of its axis, from wobbling too wildly. Without the moon, our planet's tilt might shift dramatically over time, leading to extreme chaotic changes in climate. It is a quiet, powerful partner, keeping our world steady and predictable. Scientists have even recently explored a fascinating and still debated possibility. Could the moon's influence extend even to our planet's magnetic field? Our magnetic field is a powerful invisible shield that protects us from the sun's harmful radiation. It is generated by the churning molten iron core deep within our planet. Some researchers now believe that the moon's constant gravitational tug on Earth's mantle and core may play a subtle role in keeping that internal engine running. If true, it would mean that the moon is not just a companion, but a crucial life-sustaining part of our planet's existence, a silent protector, keeping us safe from the harsh realities of space. It's a beautiful idea that the thing we look at every night to find a sense of peace may be actively, silently working to protect us all. Let's now turn our gaze inward towards the moon's inner structure. Like our Earth, it has a layered interior. There is a small solid inner core, mostly made of iron, and around that, a liquid outer core. But unlike Earth, the moon's core is tiny, only about 1/5 the size of the whole moon. Beyond that is a partially melted layer, the mantle, and then a thick rocky crust. This layered structure tells a story of a world that was once molten and hot, but slowly cooled down over time. The moon's surface, its face that we see every night, is a canvas of this history. We see towering mountains, but they were not formed by slow-moving tectonic plates as they are on Earth. Instead, they are the towering collapsed rims of ancient immense impact basins. We see deep crater scars left by billions of years of meteorite impacts. We see long winding grooves called rills, which are believed to be the paths of ancient lava rivers. And we see the dark flat plains we call Maria, which means seas in Latin. Early astronomers looking through their telescopes thought these dark patches were oceans of water. But they are not. They are fields of ancient lava that flowed and cooled, filling the deepest impact basins on the moon's near side. The moon's surface is a museum of its own past, perfectly preserved by a lack of weather. There is no wind, no rain, and no significant geological activity to erase the marks of time. A footprint left by an astronaut in 1969 will likely still be there in a million years, a ghost of our first touch. This timeless quality is what makes the moon so special. It's a world where the past is not buried, but laid out for all to see. And yet it is not completely inactive. The moon in its gentle dance with Earth experiences small tremors called moonquakes. These are not as common or as strong as the earthquakes we feel, but they are unique in their duration. A moonquake can last for up to a full hour, a slow, sustained vibration that reverberates through the moon's ancient dry crust. This is because the moon's crust is dry and fractured, like a brittle bell that rings long after it is struck. These small tremors are a reminder that the moon, though a quiet companion, is still a living, breathing world with its own internal life and its own slow, rhythmic pulse. Let us now reflect on the moon's atmosphere, or rather its lack of one. The moon is a world without a sky. Its atmosphere is so thin and wispy that scientists call it an exosphere, a veil of gas so sparse that its total mass is less than 10 tons. The pressure is unbelievably low, so low that it is essentially a vacuum. This is a world where there is no wind to blow away the dust, no air to carry sound, and no protective blanket to shield the surface from the harshness of space. It is a silent, airless world, but it is not entirely empty. Tiny particles from the sun's solar wind and gases, released from inside the moon, create this faint, ephemeral exosphere, a ghostly whisper of a sky. This lack of atmosphere, while making the moon a harsh place, is also what has preserved its history so beautifully. It is a world of extremes. When a part of the moon is in direct sunlight, the temperature can soar to 120 degrees Celsius. But in the shadowed areas where the sun never reaches, temperatures can plunge to 238 degrees Celsius, making these spots some of the coldest in the entire solar system. These wild temperature swings are a direct consequence of having no atmosphere to trap and distribute heat. The moon is a world of light and shadow, of fire and ice, a place where a single step can take you from a searing heat to a freezing cold. The dust that covers the moon's surface is called regolith. It's a fine powdery material created by billions of years of meteorite impacts, smashing rocks into smaller and smaller pieces. Astronauts described its smell as being similar to burnt gunpowder, a strange, unique scent for a world that seems so inert. The regolith is thicker in the older highland areas and thinner in the younger lava-filled Maria. This layer of dust is a physical record of the moon's long, violent history, a delicate blanket of shattered memories. And in this harsh, dry, airless world, we have now found signs of water, not in oceans or rivers, but in hidden, quiet places. Scientists have found evidence of water ice buried deep inside the permanently shadowed craters near the moon's poles. These craters, often called craters of eternal darkness, are so deep and so close to the poles that sunlight never reaches their floors, creating a natural deep freeze where ice from ancient comet impacts could be preserved for billions of years. We've also found signs of water molecules on the sunlit surface of the moon, a surprising discovery that suggests water may be created by chemical reactions between lunar rocks and hydrogen from the solar wind. This discovery of water, even in these tiny hidden forms, is a profound and beautiful thing. It means that the moon, our silent companion, is not just a dry dead rock. It holds a secret, a precious resource that could one day help future generations of explorers survive. It's a quiet promise, a whisper of hope in the vast emptiness. The moon is a testament to the idea that even in the most inhospitable places, there are things to be found, secrets to be unlocked, and new possibilities to be discovered. It is the first chapter in our journey out into the great cosmic ocean, and it is a chapter that is still being written. We have not fully explored this close neighbor, this gentle guide, and it still has so much more to teach us. So as you drift off to sleep tonight, and you perhaps catch a glimpse of the moon in your mind's eye, remember that it is more than just a light in the sky. It is a partner in our existence, a protector of our planet, a historian of its own violent past, and a key to our future. It is a world of quiet paradoxes, of fire and ice, of an eternal face and a hidden side. It is the beginning of our story, and perhaps the destination of a new one. Last night we rested in the quiet companionship of the moon, our gentle guide through the dark. We saw it as a silent traveler, a steady presence in our sky. But let's now drift back in time to a period so long ago that our minds can barely grasp it, to the very moment of the moon's birth. For our serene celestial neighbor did not appear quietly in the night. Its beginning was a cataclysm, a cosmic crash of unimaginable violence. It was a moment of destruction and creation, a fiery collision that gave us the beautiful, familiar orb we see today. The most widely accepted story of the moon's origin is known as the giant impact theory. It is a story of a young chaotic solar system, a time when worlds were still being born and cosmic crashes were common. Picture our early Earth, not yet the blue and green marble we know, but a fiery molten world, still cooling from its own violent formation. Then imagine a second planet, a celestial wanderer about the size of Mars. Scientists have given it a name from Greek mythology, Theia. This protoplanet was on a collision course with our young Earth. The impact was not a head-on smash, but more of a glancing sideways blow. A collision of this magnitude is difficult to imagine, but let's try to see it in our mind's eye. It would have been a moment of incredible chaos and energy. Theia would have been vaporized, shattered into a vast cloud of superheated rock and gas. The force of the impact was so great that it also tore away a huge amount of material from the outer layers of our early Earth, spraying it out into space. This enormous cloud of molten debris, a ring of fiery rock, was sent hurtling into orbit around our planet. For a long time, this debris cloud, a ring of shattered worlds, circled the Earth. But slowly over time, a quiet process of construction began. The particles of rock and metal in this ring, pulled by their own mutual gravity, began to stick together. They coalesced, gathering into bigger and bigger clumps, a cosmic snowstorm of accretion. And in a relatively short period of time, perhaps just a few thousand years, this great ring of debris gathered together to form a single spherical body, our moon. This theory, which sounds like something from a myth, is the one that best explains what we know about the Earth-Moon system today. It accounts for the special relationship between our two worlds, and for the fact that the moon has a much lower density than Earth. Theia and the outer layers of Earth, which were blasted into space, were made of lighter rock, while Earth's heavy iron core remained behind. This explains why the moon has a much smaller core and why it is so much less dense than our planet. It is in a way Earth's own broken-off child, born of a violent past and now forever bound to its parent. However, as with all great scientific stories, there is still a beautiful mystery at the heart of this one. When scientists began to study rocks brought back by the Apollo missions, they found something unexpected. The moon's chemical composition, particularly the types of oxygen atoms it contains, is almost identical to Earth's. This is strange. If the moon was mostly made from Theia, and Theia was a separate planet, then its chemical fingerprint should be different from ours. It's like finding a child who has the exact same fingerprints as their parent, and not their other parent. This mystery has led to new ideas, new chapters in the story. One possibility is that the impact was so violent that the Earth and the debris cloud that formed the Moon were both heated to an incredible degree, creating a huge, swirling cloud of vaporized rock. In this great cloud, the materials would have mixed together completely, like sugar dissolving in a cup of water, making the atomic makeup of both worlds nearly identical before the Moon slowly reformed. It's a testament to the immense forces at play, a reminder that the early solar system was a place of impossible extremes. This is one of those moments where science doesn't have all the answers, where we are left standing on the edge of a cosmic puzzle, invited simply to wonder at the elegance of the mystery. As our young moon cooled down, its surface began to harden, forming a thick rocky crust. But the interior remained hot and molten for a very long time, with a deep ocean of magma just beneath the surface. This molten rock ocean slowly cooled with heavier minerals sinking down, and lighter minerals, a type of rock called anorthosite, floating up to the surface. This is what created the Moon's initial surface, the light-colored ancient crust we call the highlands. These highlands are the oldest parts of the Moon, a primordial skin that has been preserved for over 4 billion years. But this new pristine surface did not last. The young solar system was still full of debris, and the Moon, a large, slow-moving target, was bombarded by a constant stream of asteroids and comets. This was a period of intense violence, what scientists call the Late Heavy Bombardment. The Moon's surface was scarred and pockmarked by countless impacts, big and small, creating the craters that we see today. Each one is a memory, a violent whisper from the dawn of our solar system, perfectly preserved for all time. The biggest impacts created enormous basins, sometimes with multiple rings of mountains circling the center. The largest of these is the South Pole Aitken Basin, an immense deep scar on the far side of the Moon. It is over 2,200 kilometers wide, making it the second largest confirmed impact crater in the entire solar system. This is a place so huge that its existence has reshaped the Moon itself, a wound so deep that it may have influenced the Moon's internal structure and its history. After the bombardment began to slow down, a new chapter in the Moon's story unfolded. From deep within its interior, molten rock or lava began to flow up through the thinner parts of the crust. This lava poured into the deep basins, created by the biggest impacts, filling them with dark, heavy rock. This is where the dark plains, the Maria, were born. These are not seas of water, but vast, flat plains of ancient lava. They are younger than the highlands, and we can tell this because they have fewer craters on their surfaces. The lava erased the old scars, creating a new smooth canvas for the next chapter of the Moon's life. A strange and beautiful mystery of the Moon is that almost all of these dark Maria are on the side that faces us. They cover about 31% of the near side, but only about 2% of the far side. Why is this? Scientists believe it might have to do with the crust. The crust on the far side of the Moon is much thicker than on the near side, like a hard, impenetrable shell. The lava inside the Moon, trying to escape, found it much easier to break through the thinner crust on our side, like water finding the path of least resistance. It is another quiet testament to the Moon's asymmetry, another piece of the puzzle that still holds our attention. The Moon's surface is also covered in a number of other fascinating features. As the ancient lava in the Maria cooled and shrank, it created long wavy lines and ridges on the surface like wrinkles on an old face. We call these wrinkle ridges, and they often trace the paths of ancient buried features. There are also long winding grooves called sinuous rills, believed to be the paths of ancient lava rivers, or collapsed lava tubes much larger and deeper than anything we see on Earth. They twist and turn across the surface, a frozen ghost river from a time when the Moon was still volcanically active. And here is another quiet, subtle story of change. We used to think of the Moon as a dead, inactive world, its geology frozen in time. But recent discoveries have shown us otherwise. Scientists have found evidence that the Moon is actually shrinking. Very slowly. Over the last billion years, It is estimated to have shrunk by about 90 meters or around 300 feet. This happens because the moon's interior is still cooling, and as it cools, it contracts. This contraction causes the surface to wrinkle and crack, forming fault cliffs that are a visible physical sign of the moon's slow internal life. It's a reminder that even our most stable companion is still changing, still evolving in ways that we are only now beginning to see. Perhaps the most mysterious and beautiful features of the moon's surface are the lunar swirls. These are bright swirling patterns that look like ghostly clouds painted on the lunar surface. They look newer than the ground around them, and they are often found in places with strong, localized magnetic fields. The most famous of these is the Reiner Gamma swirl. Scientists believe these swirls may be areas protected from the sun's solar wind by these small magnetic fields. The solar wind, a constant stream of particles from our sun, darkens the lunar surface over time, a process called space weathering. These swirls may be bright simply because they were shielded from this constant barrage, a pristine part of the lunar surface preserved by an invisible force. It is one of the most enigmatic puzzles of our closest neighbor, a whisper of a secret that we have yet to fully understand. So the moon we see in our sky is not a simple, unchanging rock. It is a world of layers of stories told in stone and dust. It is a canvas of a violent birth, a testament to a chaotic youth, a monument to the slow, patient work of time. Its surface is a history book, with each crater and each Maria telling a story of a past we can only dimly imagine. And even today, in its quiet, dark silence, it is still moving, still changing, still holding its secrets close. It is a world of paradoxes and beauty, a place that reminds us that even when we think we know everything, there is always more to discover. Let's pause and reflect on this for a moment. We as a species have a tendency to want to categorize and understand everything. We want to place things in neat boxes. The moon to many is a simple gray rock. But when we look closer, when we listen to the stories its surface tells, we find a world of immense complexity and wonder. We find a place with a history as rich and dramatic as our own, a history written in fire and stone. And we find a place that is still a living, breathing world in its own slow, quiet way. Our journey outward, our great human story of exploration, truly began with this one step. The next one is still waiting to be taken, but the stories of the past are all there, etched into the face of our most faithful companion. Last night we traveled back in time to witness the violent, fiery birth of our moon. We saw its surface, a history book etched in stone and dust. Now let's turn our gaze to a different neighbor, one that has captivated our imagination for centuries, the planet Mars. When we look up at the night sky, we can sometimes see it a tiny bright dot with a distinct orange-red color. This is the red planet named by the ancients after their god of war, a name that perfectly suits its rusty, blood-colored appearance. But Mars is not a planet of war. It is a planet of mystery, a world that feels both hauntingly familiar and starkly alien. The reddish hue that defines Mars comes from a fine layer of dust made mostly of iron oxide, the same substance that makes rust on Earth. Imagine a world-sized desert where every grain of sand and every rock is covered in this reddish powder. It's a color that speaks of a long, dry history of a planet that has endured for billions of years under a thin, unforgiving sky. Mars is a rocky planet, much like Earth, but it is a smaller, quieter sibling. Its diameter is only about half of Earth's, and its surface area is slightly smaller than all of Earth's dry land combined. It's a world that is less dense and has less gravity than our home. The gravity on Mars is only about 38% of Earth's, which means if you could stand on its surface, you would feel much lighter. A person who weighs 100 kilograms here would weigh only 38 kilograms there. This difference in gravity has shaped the planet in profound ways, allowing for the formation of some of the largest geological features in our entire solar system. A day on Mars, known as a sol, lasts about 24.5 hours, remarkably close to an Earth day. It's a familiar rhythm that makes us feel a sense of kinship with this distant world. But a Martian year, a full trip around the Sun, is much longer. It takes Mars almost 687 Earth days, or nearly 1.9 Earth years, to complete its orbit. This means that a Martian lifetime would be a very different experience, with seasons that last almost twice as long as ours. And just like Earth, Mars has seasons. This is because its axis is tilted at about 25 degrees, very similar to Earth's tilt of 23.5 degrees. This tilt causes the planet to lean towards and away from the Sun as it orbits, creating a rhythmic change in temperature and light. But Mars's orbit is more stretched out, more elliptical than Earth's. This means that its seasons are more extreme. When Mars is closest to the Sun, its southern hemisphere is tilted towards the Sun, leading to hotter, more intense summers there. When it's farthest from the Sun, the northern hemisphere has a mild summer, but the south experiences a much colder, harsher winter. This uneven orbit creates a beautiful and dramatic seasonal dance. Mars has two tiny moons, Phobos and Deimos. They are not like our round, majestic moon. Instead, they are small, irregularly shaped objects that look more like lumpy potatoes floating in space. Phobos, the larger of the two, is only about 22 kilometers wide. Deimos is even smaller, at about 12 kilometers. They are so small and close to Mars that their gravity is almost non-existent. From the surface of Mars, they would look very different from our moon. Phobos would rise in the west and set in the east, crossing the sky twice a day. Deimos would move so slowly that it would be in the sky for days at a time. Scientists believe they are likely captured asteroids drawn in by Mars's gravity in the distant past. The surface of Mars has two very different faces, a striking contrast that scientists call the Martian dichotomy. Imagine a world where the northern half is mostly flat and smooth, like a tranquil ocean that has long since dried up. This is the northern hemisphere of Mars, a vast, low-lying plain smoothed over by ancient lava flows and perhaps even a primordial ocean. Now imagine a line drawn across the planet, and on the southern side of that line, the landscape is the complete opposite. It is covered with rugged ancient highlands, deeply pockmarked with craters from billions of years of impacts. This dramatic split in the planet's geography is one of its greatest mysteries, and it tells a story of a violent past. Scientists believe that this great divide may have been caused by a single colossal impact in Mars's early history, a smash-up so big that it tore a huge chunk out of the planet's northern hemisphere, creating the smooth basin we see today. The object that hit Mars may have been as big as Pluto, a cosmic billiard ball that forever changed the face of the planet. Within this diverse landscape are some of the most impressive natural features in our solar system. The first is a colossal shield volcano named Olympus Mons, or Mount Olympus. This is not just a big mountain. It is the largest volcano in the entire solar system. To put its size into perspective, it is about 600 kilometers wide, roughly the size of the state of Arizona. From its base to its peak, it rises more than 21 kilometers, more than twice the height of Mount Everest on Earth. Because of Mars's lower gravity and lack of plate tectonics, this volcano was able to grow and grow for billions of years, a towering monument to the planet's geological past. Its slopes are so gentle that if you were standing on the top, you wouldn't even be able to see the base in the distance. You would simply be standing on a vast, gentle rise that reaches up into the thin Martian sky. The other major feature is a colossal canyon system called Valles Marineris, or the Mariner Valleys. This is a crack in the planet's crust that is so immense it stretches for about 4,000 kilometers a distance that would span the entire width of the continental United States. It drops as deep as 7 kilometers in some places, a yawning chasm of epic proportions. Earth's Grand Canyon is beautiful and impressive, but it would be lost in the vastness of Valles Marineris. Scientists believe this great canyon was formed not by water, but by the swelling of the land around the Tharsis region, where Olympus Mons is located. As the ground was pushed up, it cracked and collapsed, creating this deep dramatic scar in the planet's face. It's a testament to the powerful, slow-moving geological forces that have shaped this world. The long history of Mars is divided into 3 great chapters or time periods that tell the story of its dramatic evolution. The first is the Noachian period. This was the earliest chapter in Mars's history, from about 4.5 billion to 3.5 billion years ago. It was a time of immense asteroid impacts, a chaotic period when the planet's surface was heavily cratered. We see the legacy of this time in the southern highlands, which are full of these ancient scars. But this was also a time when Mars may have been much warmer and wetter. Scientists believe that during this period, liquid water flowed across the planet, carving out massive valleys and river channels. It was a time when Mars may have had a thicker atmosphere, and perhaps even vast oceans in its northern hemisphere. The name of this period comes from a region on Mars called Noachis Terra, a land of ancient scarred memories. After that came the Hesperian period, which lasted from about 3.5 billion to roughly 2.9 billion years ago. This was a time of huge volcanic eruptions and massive floods. The lava flowed across the planet's surface, filling in some of the ancient craters and creating the wide, smooth plains that are a key feature of Mars's landscape. It was a period of transition when Mars was a much more active world than it is today. The floods of water that may have once coursed across the planet began to diminish, and the planet started to become the cold, dry desert we know today. The name of this period comes from a broad plain called Hesperia Planum. The final and current chapter in Mars's history is the Amazonian period. This is the most recent period, which began about 2.9 billion years ago and continues to this day. It is a much quieter time, a period defined not by impacts and volcanoes, but by the slow, patient work of the wind. The surface from this time has far fewer craters, a sign that the Great Bombardment has long since ended. The forces that are shaping the planet today are primarily atmospheric. Winds whip across the surface, creating massive dust storms that can engulf the entire planet, reshaping the dunes and covering the rocks in a fresh layer of rusty dust. Olympus Mons and some of the more recent lava flows also formed during this time, a quiet final gasp of the planet's volcanic life. The name of this period comes from a flat plain called Amazonas Planitia. Even today, Mars still shows subtle signs of geological activity. Scientists have detected Marsquakes, small tremors that shake the ground below. These quakes are not as powerful as Earth's earthquakes, but they are a reminder that the planet's interior is not entirely dead. It is a slow-moving, quiet world, but it is still alive in its own way, still settling and changing after billions of years of history. This story, written in the planet's geology and its ancient scars, is why Mars is such a source of fascination for us. It is a world that we have begun to touch, to explore, to understand. We have sent our robotic messengers to its surface, and they have sent back a stream of images that have transformed our view of this distant world from a myth to a tangible place. We have seen its towering mountains, its gaping canyons, its vast, empty deserts. We have begun to read the chapters of its long, dramatic history, and we have begun to wonder what comes next. This is a world that holds the promise of discovery, a place where we might one day find the answers to some of our biggest questions. Was there ever life here? Did a second world, so like our own in its early days, ever nurture life only to see it disappear? Or is it a cold, lonely desert, a monument to a world that could have been but never was? These are the questions that will drive us, that will pull us forward, that will make us dream of one day leaving our own footprints in that rusty red dust. Mars is not just a planet. It is a promise, a riddle, and a dream. Last night, we contemplated the grand scarred history of Mars, a planet with a dichotomy of rough highlands and smooth plains, a world shaped by colossal impacts and volcanic giants. But there is one question above all others that has guided our exploration of this distant sibling. It is a question whispered by the ancient riverbeds and the ghostly outlines of deltas. Was Mars ever a watery world? And if so, could it have hosted life? The search for water on Mars is not merely a scientific pursuit. It is a search for our own reflection in the cosmos, a quest to find another place where the delicate dance of life might have once begun. Let us drift back in time once more to a Mars very different from the cold, dry desert we know today. During the Noachian period, billions of years ago, the planet was a much warmer, wetter place. The evidence for this is not subtle. It is etched into the very face of the planet. When our robotic eyes, the orbiting satellites, and the rovers looked down upon the southern highlands, they saw something remarkable. They saw networks of valleys branching out, like the veins of a leaf, flowing into what looked like ancient lake beds. They saw alluvial fans and deltas landforms that on Earth are unmistakably created when flowing water slows down and drops the sediment it was carrying. These features are not just hints. They are the ghost rivers of a long-vanished world, the silent testament to a time when liquid water coursed across the planet's surface. Some scientists believe that during this period, the vast, smooth northern plains of Mars were once covered by a deep ocean. They call it the Martian Ocean, a body of water that could have been hundreds of meters deep and as large as Earth's Arctic Ocean. The evidence for this is not direct, but it is compelling. We find signs of ancient shorelines and minerals that only form in the presence of water like hematite and jarosite on what would have been the seafloor. We have also studied the ratio of deuterium, a heavy form of hydrogen, in the Martian atmosphere, which suggests that Mars once had a much larger amount of water than it does today. The deuterium is a memory of a time long past, a subtle chemical echo of a watery world that has since disappeared. This ancient watery Mars is a world we can only dream of. A world with a thicker atmosphere, with a sky that might have been blue, and with rain that fell upon its surface feeding the rivers and filling the oceans. A world where the sun, though dimmer than on Earth, warmed the water just enough for it to exist in its liquid form. It is a beautiful, melancholic picture, a ghost of a planet that might have been. But what happened to all that water? The answer is a story of planetary loss. Over time, Mars lost its protective magnetic field. Without this shield, the solar wind, a constant stream of energetic particles from the sun, began to strip away its atmosphere molecule by molecule. The thin atmosphere, in turn, could no longer maintain the pressure and warmth needed for liquid water to exist on the surface. The water that remained either froze into ice, buried deep beneath the surface, or was broken apart by the sun's ultraviolet radiation, with the hydrogen atoms escaping into space. Mars became the cold, dry, rusty desert we see today, a monument to a world that lost its lifeblood. The quest for water did not end with the discovery of its ancient past. The modern search has been a slow, patient hunt for water in its hidden contemporary forms. And we have found it. We have discovered that Mars is a world of ice. The polar ice caps, which we can see from Earth, contain a massive amount of frozen water, enough to cover the entire planet in a layer of water, about 11 meters deep if it were to melt. But the ice is not just at the poles. We have found huge quantities of underground ice buried beneath the surface, particularly in the northern plains. This ice is protected from the thin atmosphere by a layer of dust and soil, a hidden reservoir of a long-vanished past. One such discovery in the Utopia Planitia region holds as much water as Lake Superior on Earth, a frozen lake buried beneath the red dust. But the most tantalizing question remains, is there any liquid water on Mars today? The conditions on the surface, with its low pressure and cold temperatures, make it impossible for liquid water to exist for long. It would either freeze instantly or boil away into a gas. But there may be an exception. Scientists have observed mysterious dark streaks on the steep slopes of craters and valleys, streaks that appear in the warmer Martian summers and fade away in the colder months. These features, known as recurring slope lineae, were once thought to be caused by liquid water, possibly salty water or brine, flowing just beneath the surface. The salt would lower the freezing point of the water, allowing it to remain liquid for a short time. This was a profoundly exciting idea, a whisper of a living Mars. But the story has become more complicated. Later studies have suggested that these streaks might be caused by dry, grainy flows of dust and sand, with little to no water involved. The debate continues, and the mystery remains. Is Mars a world of no liquid water? Or is there a quiet, invisible trickle of briny fluid that flows for a short time in its sunlit summers? The truth is still hidden, buried beneath the dust and the sand, waiting for us to find it. It is a slow, patient riddle that we are only beginning to solve. And this, of course, brings us to the ultimate question. The one that has fueled our imagination for so long. Is there life on Mars? The first time we truly went looking for life was with the Viking missions in the 1970s. These two landers carried a suite of sophisticated experiments designed to detect microorganisms in the Martian soil. One of the experiments produced a result that was both thrilling and confusing. It showed a temporary increase in carbon dioxide production when the soil was exposed to water and nutrients, a result that on Earth would be a strong sign of life. But the other experiments did not show any evidence of life. The results were inconclusive, and the scientific consensus at the time was that Mars was a lifeless world, a cold, sterile desert. But one of the scientists involved, Gilbert Levin, has stood by the idea that life may have been discovered, and the debate continues to this day. It's a testament to the ambiguity of the cosmos, a reminder that the universe does not always give us clear answers. Our modern search for life on Mars is much more sophisticated. Our rovers, like Curiosity and Perseverance, are not just looking for living things. They are looking for biosignatures, the chemical and physical signs that life once existed. They are looking for the ghosts of a past life, the fossilized remnants of ancient microorganisms in the rocks. Perseverance, in particular, is a roving laboratory, a geologist, a chemist, and a ghost hunter all in one. It has been collecting rock samples in a region that was once a river delta, a place where water and life might have once converged. The samples it has collected will one day be returned to Earth, where we can study them with our most advanced instruments, looking for the faintest whisper of a fossil, the quietest chemical signature of an ancient life. One of the most intriguing discoveries in this modern search has been the presence of methane gas in the Martian atmosphere. Methane is a gas that is often produced by living things on Earth, but it can also be produced by non-biological processes, such as chemical reactions between water and certain types of rocks. The levels of methane on Mars are tiny, but they fluctuate with the seasons, which suggests that something is actively producing it. Is it a sign of microbial life living deep beneath the surface, protected from the harsh radiation and the cold? Or is it a geological phenomenon that we don't yet understand? We don't know. It is another piece of the cosmic puzzle, a tantalizing hint that keeps us coming back for more. The search for water and life on Mars is a story of slow, patient, and methodical work. It is a story told not in a single dramatic moment, but in thousands of images, in millions of data points, and in the careful analysis of tiny rock samples. It is a testament to the enduring curiosity of the human mind and to our quiet, persistent belief that we are not alone in this vast universe. The Red Planet, this desert world of rust and ice, holds a secret that, if unlocked, could change our understanding of our place in the cosmos forever. It is a quiet promise, a whisper from a distant world, a beautiful invitation to keep exploring, to keep wondering, and to keep dreaming of what might have been and what might still be. Last night we contemplated the ghost rivers and hidden ice of Mars, the subtle clues that whisper of a watery past, and perhaps an enduring microscopic life. But how did we come to know these things? The story of our understanding of Mars is a story of a slow, patient, and sometimes mistaken journey of exploration. It is a journey that began with a myth, a beautiful fiction that inspired generations, and it has evolved into a methodical, painstaking search for the truth. The first chapter of this story was written not with rockets and robots, but with glass and mirrors. For centuries, astronomers gazed at Mars through their telescopes, watching its seasons change and its polar ice caps grow and shrink. They saw a world with continents and oceans, a world that seemed so similar to our own. But it was in the late 19th century that the most beautiful mistake of all was made. An Italian astronomer named Giovanni Schiaparelli, using a telescope in Milan, drew the first detailed maps of Mars. He saw a network of long straight lines crisscrossing the planet's surface and called them canali, which in Italian simply means channels or grooves. But when his word was translated into English, it became canals. This single word sparked a fire in the human imagination. It suggested that these were not natural features, but artificial waterways built by an intelligent civilization to transport water from the poles to the dry equator. An American astronomer named Percival Lowell, inspired by these maps, built his own observatory in the clear skies of Arizona and spent years studying Mars. He saw what he wanted to see, a vast, dying world with an advanced civilization desperately building canals to survive. He wrote books and gave lectures, and the idea of Martians of a neighboring civilization became embedded in our culture. A beautiful, haunting myth that filled our minds with wonder and a sense of cosmic companionship. But as our telescopes grew bigger and more powerful, the canals began to fade away. They were not real. They were an optical illusion, a trick of the eye caused by the faint, irregular patterns on the planet's surface. The myth of the Martians was not a failure of science, but a triumph of the human imagination. It was a story we told ourselves, a beautiful fiction that drove our curiosity and our desire to explore. It was the first step in our journey, a dream that we pursued until we could finally see the truth. The truth began to reveal itself in the 1960s with the dawn of the robotic era. Our first messengers were the Mariner missions. Mariner 4, launched in 1964, was the first spacecraft to fly past Mars and send back pictures. Its images showed a heavily cratered moon-like surface, a barren and lifeless world that shattered the romantic myth of the canals. Mariner 9 in 1971 was the first spacecraft to orbit Mars, and it completely changed our understanding once again. It arrived during a colossal planet-engulfing dust storm, and as the storm slowly cleared, it revealed the monumental features we know today: Olympus Mons, the towering volcano, and Valles Marineris, the Great Canyon. It showed us a world of immense geological grandeur, a world that was far more complex and interesting than we had ever imagined. The next great chapter was written by the Viking missions in 1976. These were our first successful landers on the surface of Mars. Viking 1 and Viking 2 were stationary laboratories, a pair of sentinels that landed in two different parts of the planet. They took our first panoramic images of the rusty red desert, and they carried the experiments we discussed last night, the ones that searched for life and found a tantalizing, yet inconclusive result. The Viking missions gave us our first real taste of what it was like to be on Mars, to feel the thin air and see the rusty red dust with our own eyes. But the real age of discovery, the chapter that we are still writing today, began with the rovers. These are not stationary landers. They are our robotic feet on the ground, our tireless explorers. The age of rovers began with the tiny Sojourner rover in 1997, a small six-wheeled vehicle that trundled across the surface and proved that a rover could work on Mars. It was the first footprint of a new kind of exploration. Then came the twin rovers, Spirit and Opportunity, in 2004. These two rovers were not just machines, they were personalities. They were designed to last for 90 days, but they lived for years, for a decade, in the case of Opportunity. They were geologists driving across the surface, studying rocks and soil, and looking for evidence of water. Opportunity found it first discovering minerals that only form in the presence of water. Its mission was a masterclass in persistence and discovery, a slow, patient hunt for the truth. It was a story of a machine that exceeded all expectations that became a part of our cosmic mythology. The next great explorer was Curiosity in 2012. Curiosity was a quantum leap in technology, a giant car-sized rover with a sophisticated laboratory on board. It landed in Gale Crater, a place that was once a lake bed, and its mission was to determine if Mars ever had the conditions to support life. Curiosity drilled into rocks, analyzed samples, and confirmed that Mars once had the chemical ingredients necessary for life, a testament to its watery past. It has been a tireless messenger, sending back a stream of images that have reshaped our understanding of Mars, from a barren desert to a world of immense geological diversity, a place with ancient riverbeds, towering cliffs, and a rich, complex history. And the newest explorer is Perseverance, which landed in 2021. Perseverance is a culmination of all the knowledge we have gained. It landed in Jezero Crater, a place that was once a river delta, and its mission is to look for signs of ancient life. But its most important job is not to find life, but to collect samples. It is drilling into the rocks, taking tiny cores of Martian soil and sealing them in tubes. These are not just rocks. They are time capsules, a piece of Mars that will one day be returned to Earth. They are the most precious cargo in the universe, the promise of a future discovery. This brings us to the next most ambitious chapter in our story, the Mars Sample Return Mission. This is a joint effort between NASA and the European Space Agency, a complex and intricate ballet of robotic spacecraft. The plan is to send a lander to Mars that will pick up the samples that Perseverance has collected. The lander will have a small rocket on board, a Martian rocket, that will launch the samples into orbit around Mars. Then an orbiter will be sent to Mars to rendezvous with the sample container in orbit, capture it, and return it to Earth. It is a mission that is a testament to our ambition and our ingenuity, a slow, patient, and methodical process that will culminate in us holding a piece of another world in our hands for the first time. And beyond this, of course, lies the ultimate goal: human missions to Mars. This is the dream that has driven us from the beginning, the one that was born in the myth of the canals. It is a challenge of immense proportions. The journey itself is long and dangerous, a 9-month trip through the cold, harsh vacuum of space, exposed to radiation and cosmic rays. We would need to build spacecraft that are not just machines, but self-contained worlds capable of sustaining life for years. And once we arrived, we would face a world of extremes, a world with no breathable air, with intense radiation, and with temperatures that swing wildly from one extreme to the other. But the dream is not just to get there. It is to stay there. It is to build a human presence on another world, a permanent foothold in the cosmos. Companies like SpaceX have already laid out a vision for this future, a future of reusable rockets and a self-sustaining Martian colony. It is a vision of a new beginning, a new chapter in the human story, a time when we are no longer confined to a single planet. It is a future that is not a fantasy, but a real tangible goal that we are working towards every day. The journey to Mars, from the myth of the canals to the reality of the rovers, is a story of our own growth. It is a story of how we have learned to see, to question, and to explore. It is a story of how we have moved from a place of romantic childlike wonder to a place of methodical scientific patience. But the wonder has not disappeared. It has simply been transformed. The myth of the Martians has been replaced by the far more profound reality of a world with ancient ghost rivers, with hidden ice, and with the quiet, persistent possibility of life. And so, as we look to the future, as we dream of a day when the first human footprints are left in that rusty red dust, we are not just thinking about a journey to another world. We are thinking about the journey of our own species, a journey of self-discovery, of pushing our limits, of reaching for the stars. And in a way, that journey has already begun. Every time we send a robot, every time we analyze a rock, every time we ask a question, we are taking a small, quiet step on the road to Mars. We've spent our nights traveling far first to the silent companion of the moon, and then to the rusty, enigmatic desert of Mars. These are journeys of the mind and, for now, of our tireless robotic messengers. But let's now turn our attention back to a world that is much closer to home, a world that is both a part of us and a world apart. Let's speak of a creation that floats above us right now, a beacon of light and a symbol of our grandest, most peaceful ambitions, the International Space Station, or the ISS. The ISS is not just a machine. It is a living, breathing testament to what we can achieve when we choose to work together. It is a floating city, a laboratory, and a home. It is a fusion of rivalries, a monument to a time when two superpowers raced to the heavens, only to find that the ultimate destination could only be reached by joining hands. The ISS is the ultimate collaboration, a project of 5 major space agencies and a multitude of countries. A quiet, powerful statement that the challenges of space are best met as one species. Imagine it for a moment, a magnificent structure orbiting high above the Earth, traveling at an incredible speed of over 27,000 kilometers per hour. It makes one full lap around our planet every 93 minutes, which means that every day the astronauts on board witness 16 sunrises and 16 sunsets. It is a perspective on our world that only a handful of people have ever experienced, a view that is both breathtakingly beautiful and deeply humbling. From that vantage point, there are no borders, no divisions, just the fragile blue-green marble that is our home. The ISS itself is a masterpiece of engineering, a complex and elegant structure that looks like a giant gleaming insect in the sky. Its most eye-catching features are its massive solar arrays, a series of gigantic wings that span over 73 meters long, enough to cover a football field. These wings are made of thousands of solar cells that convert sunlight into the electricity that powers the entire station, giving it life and energy in the cold vacuum of space. They are the lungs and heart of this floating city, the source of its power and its existence. The core of the station is a collection of pressurized modules, like different rooms in a house, each with a specific purpose. There are laboratories for science, living quarters for the crew, airlocks for spacewalks, and storage areas for supplies. These modules are divided into 2 main parts: the Russian Orbital Segment, or ROS, built by Russia's space agency, and the United States Orbital Segment, or USOS, built by the US, Europe, Japan, and Canada. This physical division is a powerful reminder of the 2 separate paths that once led to this single shared destination. The station is a home for everyone, a place where people from different countries and cultures live and work together, a microcosm of our planet floating in the silent emptiness of space. But the story of the ISS is even more profound than its physical presence. It is a story of how we overcame our differences, of how we moved beyond the fierce competition of the space race to a place of cooperation. In the 1970s, as the Cold War began to thaw, a historic joint mission called the Apollo-Soyuz test project took place. It was the first time that spacecraft from the United States and the Soviet Union docked together in space, a symbolic handshake in the heavens that planted the seeds of a new era. But it would take many years and many political changes for that seed to truly bloom. In the 1980s, the US began planning a new modular space station called Freedom, a project that was meant to be America's own home in space. At the same time, the Soviet Union was building a new station of its own, Mir 2. But as costs mounted and political landscapes shifted, both projects ran into financial and logistical trouble. It became clear that neither nation could build such a grand, ambitious project alone. In a historic moment of political and scientific pragmatism, the 2 nations decided to combine their efforts. In 1993, the United States and Russia announced a plan to build a single joint space station. This would eventually become the ISS. It was a beautiful, powerful act of diplomacy, a testament to the idea that the universe is too big for us to explore alone. The actual building of the ISS began in 1998, a slow and painstaking process that took over a decade to complete. The first piece, the Russian-built Zarya module, was launched on a rocket. 2 weeks later, the American Unity module was launched on a space shuttle, and the two pieces were joined together in orbit. It was a cosmic handshake, the first physical connection between two former rivals. The station grew piece by piece, module by module, with space shuttles and Russian rockets delivering new parts to be assembled in a delicate, dangerous ballet of spacewalks and robotic arm maneuvers. It was a long, slow process, a testament to the incredible patience and ingenuity of the thousands of people who worked on it, a physical embodiment of a shared dream. And in the year 2000, the station became a home. The first long-term crew, Expedition 1, arrived on November 2nd, and since that day, a period of over 24 years, humans have lived on the ISS continuously. It is a profound, beautiful milestone. For the first time in our history, we have established a permanent presence beyond our home world. There has always been a human presence in space, a small, fragile group of people living and working in a small, self-contained world, a little piece of Earth floating high above us all. This continuous human presence is a quiet and powerful legacy. The people who have lived on the ISS, a total of 279 people from 22 different countries by early 2024, are not just scientists and engineers. They are pioneers, diplomats, and guardians of a shared dream. They have lived in a world where the sun rises and sets 16 times a day, where the ground is always below their feet, and where the most powerful lesson they learn is the fragility and beauty of our home world. They are a testament to the idea that we can overcome our differences and work together for a common cause, that our shared humanity is far more powerful than our divisions. The ISS is also a world of constant motion and change. Astronauts arrive and depart on a regular schedule, with new crews arriving every few months, bringing with them new experiments, new supplies, and a fresh perspective. It is a constantly evolving ecosystem, a place where people from different cultures and backgrounds come together to live and work in a small, confined space. It is a testament to the human capacity for adaptation, for cooperation, and for finding a sense of home in the most alien of environments. The ISS is our first great step into the cosmos, a place where we are learning to live and work in space, to understand how our bodies respond to the harsh realities of microgravity and radiation, and to prepare for the day when we will travel farther to the moon, to Mars, and beyond. It is a living laboratory, a training ground, and a symbol of our grandest, most peaceful ambitions. It is a light in the night sky, a quiet, powerful reminder that we are all on this journey together. And as we continue our slow drift through the cosmos, we can rest in the knowledge that this beautiful, improbable floating city is still up there, a beacon of hope and a testament to the enduring power of the human spirit. Last night we rested in the glow of the International Space Station, a beacon of human collaboration and a testament to our shared dreams. We saw it as a floating city, a home for astronauts from all over the world. But how did this improbable city in the sky come to be? Its creation was not a single launch, but a meticulous, years-long cosmic ballet, a delicate dance of machines and humans working together in the vacuum of space. The assembly of the ISS was a triumph of choreography and precision. Imagine a project where each piece is built in a different country, thousands of miles apart, and then launched separately into orbit, where they must be carefully and perfectly joined together. This is exactly what happened. The first piece, the Russian-built Zarya module, was launched in 1998, a self-contained unit that provided power and propulsion. 2 weeks later, the American Unity module was launched aboard the Space Shuttle Endeavour, and the two pieces were brought together by a giant robotic arm, the Canadarm2. It was a silent, slow-motion handshake. In space, a powerful first connection between two former rivals. The station grew piece by piece over dozens of space shuttle and Russian rocket missions. Each launch was a delivery of a new room, a new corridor, a new set of solar wings. Astronauts performed countless spacewalks or extravehicular activities, EVAs, to manually bolt on new components, connect wires and set up new systems. It was a construction project on an impossible scale, a home built not on solid ground, but in the thin, cold darkness of space with only the stars and the gentle curve of the Earth to guide them. This process was a powerful metaphor for the collaboration itself. There were no manuals that covered every contingency, no blueprints for every unexpected problem. The astronauts and engineers from different nations speaking different languages had to work together to improvise and to solve problems as a single unified team. The ISS is in a way a physical embodiment of this teamwork, with every module and every truss a testament to the fact that our differences, when put to a common purpose, can create something far more beautiful and enduring than anything we could have built alone. The completion of the station with all its modules and its immense solar arrays in place was a culmination of this grand cosmic ballet, a moment of profound achievement that marked the end of the building phase and the beginning of the research phase. And so, what is the purpose of this floating city? It is first and foremost a laboratory unlike any other on Earth. Its primary tool is microgravity, the state of near weightlessness that objects experience when they are in a constant state of freefall around the Earth. Though gravity is still present about 90% as strong as it is on Earth, the constant orbital fall cancels it out, creating an environment where everything floats. This unique environment allows scientists to study how things behave without the dominant force of gravity affecting them. It's like a quiet, invisible hand has been removed from all of our experiments. In microgravity, fire behaves differently. It doesn't flicker and burn in a teardrop shape. It forms a perfect spherical ball, a beautiful controlled flame that allows scientists to study combustion in a way that is impossible on Earth. This research can lead to more efficient engines and safer ways to handle fire. In this weightless environment, we can also grow new materials such as perfect protein crystals, which are crucial for medical research and drug design. On Earth, gravity can cause these crystals to clump and deform, but in microgravity, they can grow to be much larger and more pure. We can also grow three-dimensional human tissue, a holy grail of medical research that could one day lead to organ transplants and new cures for diseases. The ISS is a place where we are learning to use the very fabric of space to heal and to create. And in this cosmic laboratory, there is one instrument that stands out, a cosmic detective with a singular mission. The Alpha Magnetic Spectrometer, AMS, is a powerful scientific tool that is attached to the outside of the ISS. It is a particle detector, a giant complex magnet that is searching for something we have never seen: dark matter and antimatter. Imagine the universe as a vast, quiet ocean. We can see the surface, the stars and galaxies. But beneath that surface, there is something we cannot see, something that makes up most of the universe. This is dark matter. The AMS is like a fishing net that is cast out into that ocean, trying to catch the tiniest, most subtle signs of this invisible substance. It is searching for particles that are created when dark matter annihilates itself, a faint whisper that could tell us what this mysterious substance is made of. The AMS has been collecting data for over a decade, a tireless search for a profound answer to one of the biggest mysteries of the cosmos. The AMS also searches for antimatter, the ghostly opposite of the matter that makes up our universe. We believe that when the universe was born, there was an equal amount of matter and antimatter, and that they should have annihilated each other, leaving behind nothing but energy. But for some reason, a tiny imbalance was created, and that tiny imbalance is why we exist. The AMS is searching for cosmic rays of antimatter, hoping to find a hint of a distant star or galaxy made of antimatter, a ghost world that could rewrite our understanding of the universe's creation. The search is a quiet, patient one, but the potential discovery is immense. But perhaps the most important research on the ISS is the research that is being done on the very people who live there. Our bodies, which evolved in the embrace of Earth's gravity, do not fare well in microgravity. Our muscles get weaker, our bones become thin and fragile, and our body fluids shift around. Our vision can even change. This medical research is not just about the health of the astronauts. It is about our future as a species. If we are to ever make the long journey to Mars, a trip that will last over a year and a half, we must first understand how to keep our bodies healthy in space. We must find a way to mitigate the effects of bone loss, to keep our muscles strong, and to protect ourselves from the constant barrage of radiation. The ISS is our training ground, our medical school in the sky. It is where we are learning to be a multi-planetary species. The research is both simple and profound. Astronauts perform ultrasound scans on themselves, guided by doctors on Earth, to monitor their health. They exercise for hours a day to keep their muscles from atrophying. They even do experiments on how tiny life forms like bacteria respond to the harsh realities of space and whether or not they could travel from one world to another, a theory known as panspermia. One of the most important experiments is the twin study, where one twin lives on the ISS for a year and the other lives on Earth. By studying the differences between them, scientists can get a better understanding of how space affects the human body. The results of these studies will not only help us to plan future missions to Mars, but they will also lead to a better understanding of our own bodies, of how we age, and of how we can live healthier lives here on Earth. The ISS, this floating city in the sky, is a testament to the human capacity for wonder, for collaboration, and for scientific discovery. It is a place where we are learning to be a spacefaring species, where we are searching for the secrets of the cosmos, and where we are learning to heal and to create. It is a quiet, powerful symbol of our shared future, a beacon of light that reminds us that no matter how big the universe is, our ambition to explore, it is even bigger. And as we drift off to sleep, we can rest in the knowledge that this improbable, beautiful, and important place is still up there circling our world, a home for a handful of people who are living the dream of our entire species. Last night, we explored the inner workings of our floating home in the sky, the International Space Station, a place of cosmic ballets and profound scientific questions. We saw how this collaboration born from rivalry has become our first permanent foothold in space, a training ground for what comes next. Now let's turn our gaze to that future, to the next great chapters in our story of exploration. For our journey is not ending. It is just beginning. We are not just dreaming of the stars anymore. We are making plans. The first step in this new era of exploration is a return to our closest companion, the Moon. The old Apollo missions of the 20th century were a triumph, a series of brief heroic visits to plant a flag and collect a few rocks. They were a testament to what we could do in a moment of intense ambition. But the next step is different. The goal now is not just to visit, but to stay. This new effort led by NASA's Artemis program is not a race, but a methodical patient building project. The vision is to establish a sustainable human presence on the Moon, a sort of lunar village where astronauts can live and work for extended periods. This shift in ambition from a quick sprint to a long marathon is a profound one. It's like the difference between a tourist taking a picture and a pioneer building a home. The Artemis program aims to send the first woman and the first person of color to the lunar surface, a beautiful and powerful testament to how far we have come as a species. The plan involves building a space station orbiting the Moon, called the Lunar Gateway, which will serve as a staging ground for missions to the surface. From there, astronauts will travel to the lunar surface using a new landing system, where they will set up temporary camps and begin the long, slow work of building a permanent presence. This is a future that is being built not just by governments, but by private companies working together. NASA is partnering with a number of commercial firms to build the landing systems, the communication networks, and the infrastructure needed for a lunar base. There are even plans to test a 4G network on the Moon, a small mundane detail that speaks volumes about the goal of making this alien world feel a little more like home. This new approach, this blending of public and private ambition, is a testament to the idea that the future of space exploration will be built by many hands, not just a few. The goal of this lunar presence is not just to do science, but to learn to live on another world. We will learn to use the moon's own natural resources, such as the water ice hidden in its permanently shadowed craters, to make rocket fuel and to sustain a human settlement. We will learn to build habitats that can protect us from the extreme temperatures and the constant barrage of radiation. We will learn to survive, to thrive, and to make a new kind of home in a world without an atmosphere or a sky. It is a slow, patient, and methodical process, a testament to the idea that our journey into the cosmos is not a single leap, but a series of small, careful steps. But this new era of exploration also raises some profound ethical questions. As we prepare to make a permanent home on the moon, we must ask ourselves, what is our responsibility to this world? The moon is a pristine, untouched environment, a museum of its own history. Should we treat it as a resource to be exploited or a partner to be respected? The dust stirred up by our landings and our vehicles can travel for miles, a kind of lunar pollution that can contaminate scientific instruments and change the pristine environment. How do we balance our ambition to explore with our responsibility to preserve? One event that brought this question into sharp relief was the so-called tardigrade affair in 2019. A private Israeli spacecraft carrying microscopic life forms called tardigrades crashed on the moon, and it is possible that these incredibly resilient creatures, also known as water bears, may have survived the crash. This raised serious questions about the lack of international rules to protect the moon from biological contamination. The moon may seem lifeless, but it is a world of its own with its own delicate, untouched environment. How do we ensure that we do not bring our own earthly life, our own germs and our own biology, to a world that has been pristine for billions of years? It is a question that we are only now beginning to grapple with, a quiet, philosophical dilemma that is a direct result of our own ambition. And while the moon is our first stop, our ultimate destination, the great dream of our species is a journey to Mars. The red planet, with its ancient ghost rivers and its silent, dusty plains, has captured our imagination for centuries. The dream of walking on its surface, of seeing its two tiny moons rise in the sky, is a powerful one. And for the first time, this dream is not just a fantasy. It is a real, tangible goal that we are actively working towards. The vision for colonizing Mars is as bold as the dream itself. Companies like SpaceX, with their powerful Starship launch vehicle, have laid out a plan to make it a reality. Their goal is not just to send a few astronauts to Mars, but to establish a permanent, self-sustaining human presence on the planet. This would require an immense fleet of spacecraft, carrying not just people, but all the supplies and equipment needed to build a city from scratch. It is a vision of a new kind of human, a Martian, a person born and raised on another world. The challenges of such a project are almost unimaginable. Mars is a world of extremes. There is no breathable air, the radiation is intense, the temperatures are wild, and the planet is subject to colossal dust storms that can last for months. To live there, we would need to build habitats that are completely sealed, that can protect us from the harsh environment. We would need to find a way to make our own oxygen, our own water, and to grow our own food. We would need to use the planet's own resources, such as the water ice buried beneath the surface, to survive. This is not just a scientific project. It is a project of human ingenuity and resilience on an unprecedented scale. But the rewards of such a journey would be just as immense. It would be a profound shift in our place in the cosmos, a moment when we would no longer be a one-planet species. It would be a kind of cosmic insurance policy, a way to ensure that the human story can continue even if something catastrophic were to happen to Earth. And it would be a source of inspiration, a new frontier that would drive our scientific and technological progress for generations. The journey to Mars is a long one, a journey that will likely be measured in decades, if not centuries. But the first steps are being taken now. We are sending robots that are designed to look for the resources we will need to survive, to learn about the planet's environment, and to prepare the way for the day when the first humans will step out of their ship and onto that rusty red ground. The dream of Mars is a dream of our future, a dream of what we can become. It is a dream of a new kind of humanity, a humanity that has finally found its place among the stars. We have journeyed far in our quiet musings from the familiar island of the Moon to the rusty deserts of Mars. We have seen our floating city in the sky, a testament to what we can do together. And we have dreamed of a future where we build homes on other worlds. But now, let us turn our gaze to the most distant and profound dream of all the stars themselves. Let's speak of a world that is not a planet, but a sun, and a journey that is not to a neighbor, but to the very next house down the cosmic street. The closest star to Earth after our own sun is called Proxima Centauri. Its name is a beautiful promise, for it is Latin for the nearest of Centaurus. It is located about 4¼ light years away from us, a distance that is both incredibly vast and on a cosmic scale surprisingly small. It's the first stop on any interstellar journey, the first star beyond our own to which we could ever hope to travel. But if you were to look for it in the night sky, you would not see a bright blazing star. Proxima Centauri is a tiny unassuming star, a red dwarf that is so faint you cannot see it without a powerful telescope. It has only about 12.5% of the sun's mass, and its diameter is about 1/7 that of our sun, or roughly 1½ times the size of Jupiter. It is a quiet, gentle star, a cosmic ember that burns with a soft, enduring glow. Yet this tiny star holds some big surprises. Proxima Centauri is what scientists call a flare star. This means that from time to time, it suddenly and violently becomes much brighter due to intense bursts of magnetic energy. Imagine a calm, quiet fire that suddenly and without warning shoots out a powerful bright flare. These flares can produce powerful X-rays, a reminder that even our gentle neighbors can be wild and unpredictable. These bursts are a powerful and dangerous part of Proxima's personality, and they would be a major challenge for any life that might exist on its planets. The most profound thing about Proxima Centauri, however, is its sheer longevity. Because it is so small, it burns its hydrogen fuel incredibly slowly. While our sun has a lifespan of about 10 billion years, Proxima Centauri is expected to burn for an astounding 4 trillion years. It will continue to shine long after our sun has died, long after our planet has been consumed, a quiet, eternal ember in the dark. It is a testament to the idea that in the cosmos, size does not always correlate with power. Sometimes the smallest and the gentlest things are also the most enduring. And what about the planets that orbit this quiet star? For a long time, we didn't know if there were any. But in recent years, with our new, more sophisticated instruments, we have found something remarkable. We have found a confirmed planet, Proxima Centauri b, and 2 more that might be real. Proxima Centauri b is a world that has captured our imagination. It is a planet that is slightly heavier than Earth, and it orbits its star at a distance of about 7.5 million kilometers, much closer than Mercury is to our sun. But because Proxima Centauri is so much dimmer than our sun, this planet actually sits within the star's habitable zone, the region where temperatures might be just right for liquid water to exist on the surface. This is a profoundly exciting possibility. But it is not a promise of life. Because Proxima Centauri is a flare star, this planet is constantly bathed in powerful bursts of radiation, which could have stripped away its atmosphere long ago. It is also likely to be tidally locked, which means that one side of the planet is in eternal searing daylight, while the other is in perpetual freezing night. It is a world of extremes, a world that is both a tantalizing possibility and a daunting challenge. The existence of life on such a world is a beautiful open question, a cosmic riddle that we are only just beginning to ask. The discovery of this planet and the others that may be there brings us to the ultimate dream of our species, interstellar travel. The light year which we learned about on our first night is not just a unit of distance, it is a measure of an almost insurmountable barrier. Our fastest spacecraft, like Voyager 1, is traveling at about 17 kilometers per second. At this speed, it would take over 73,000 years to reach Proxima Centauri. It's a journey that is not just long, it is a journey that is impossible for a single human life to complete. But our minds are not bound by the limitations of our bodies. And so we dream of faster ways to travel. We dream of nuclear pulse propulsion, a concept that involves using tiny nuclear explosions to propel a spacecraft to incredible speeds. We dream of fusion rockets of engines that use the very power of the stars to carry us between them. And we dream of even more futuristic ideas. Ideas that sound like something from a fantasy novel. One of the most ambitious and beautiful of these ideas is called Breakthrough Starshot. It is a plan to send a fleet of tiny unmanned probes to the Alpha Centauri system, powered not by rocket fuel, but by light itself. The plan involves building a massive array of powerful Earth-based lasers that would shine a light on a tiny sail-like probe, pushing it to a speed of 20% the speed of light. At this speed, the probe could reach Proxima Centauri in just over 20 years, a journey that for the first time in our history would be a matter of decades, not millennia. Once there, these tiny messengers would take pictures and gather information about the star and its planets, sending the data back to Earth in a journey that would take a little over 4 years. It is a beautiful, audacious plan, a testament to the idea that we can use our ingenuity to overcome the immense barriers of the cosmos. It is a plan that is not just about a machine. It is about a dream of reaching out and touching another star, of getting our first real look at a world that is not our own. And with this, our journey comes to an end. We have traveled far from the quiet companionship of the moon, to the ancient history of Mars, to our floating city in the sky, and finally, to the distant fiery whisper of another star. We have explored not just worlds, but ideas. We have contemplated the meaning of time, of distance, of cooperation, and of our place in the great cosmic dance. We are small, fragile creatures on a tiny blue-green marble. But we are also the creatures who can look up at the night sky and ask a question. We are the creatures who can imagine other worlds and dream of traveling to them. We are the creatures who can build a floating city in the sky and who can dream of sending a tiny ship powered by a beam of light to the nearest star. This, more than anything, is our true nature. The universe is vast and mysterious, and we have barely begun to scratch the surface. We do not have all the answers. The origin of the moon still holds a mystery. The presence of life on Mars is still a question, and the idea of interstellar travel is still a dream. But this is not a failure. It is an invitation to keep wondering, to keep questioning, to keep dreaming. For the greatest journeys are not just about the destination. They are about the act of traveling. And the greatest discovery of all is not a new world, but a new understanding of ourselves. So as you close your eyes and drift off to sleep, let the vastness of the universe wash over you, and find peace in the beautiful, profound, and unending mystery of it all.